Hello, everybody. I'm going to discuss the fundamental techniques of drawing automatic pneumatic circuits in this video. I'll try to keep the video short and to the point. Um, so this video is targeted to people who are in the post-secondary level and have the necessary background for pneumatics and automation. So I will not really go into the basics of how to do automations and all. So it's a simple video to discuss the philosophy and the fundamental method of how you can start drawing a pneumatic circuit which has automation in it. Okay, hopefully this will be helpful for the preparation of your pneumatics exams. So let's start with a question here on the screen. Draw a pneumatic circuit using two double-acting cylinders, A and B, in a sequence, A minus, B minus, A plus, B plus. That means A retracts, then B retracts, then A extends, and finally B extends. And when you design this, draw this circuit, you must fulfill the following conditions. Number one being, initially both cylinders should be fully extended. So the initial position of the cylinders are AB plus. That means both cylinders are in the extended position. Number two, there are two modes of operation, auto and manual. So there must be two modes. In one which the cycle runs A minus, B minus, A plus, B plus, and then again repeats A minus, B minus, A plus, B plus, all by itself indefinitely. And in the other mode, it's manual, where part of it would be depending or awaiting a human input. And that's usually the beginning of the circuit, meaning after both A and B has extended, then you have to restart the cycle manually, and then it will continue from B minus, A plus, B plus. Only the A minus, which is the beginning of the cycle, you have to do it by some manual operation, like pushing a lever or a button or something like that. It also says in point 3, in manual mode, pressing a push button briefly, like sending a pulse briefly, follow a laser, will start the cycle by retracting cylinder A. Once A retracts, it retracts slowly. So there is some speed control you have to keep in mind at any desired speed. So some speed control adjustment going on. So you can use, because it's a pneumatic circuit, you can always use a meter out to be on the safe side. After which B will retract very fast. So that gives you some hint towards using a quick exhaust valve. Then A will extend, causing B to extend afterwards. Then we go to step 4 or condition 4. In the auto mode, 4 roller valves will control the circuit autonomously in a sequence as A minus, B minus, A plus, B plus until interrupted. And when you interrupt it, the circuit will first go to its default state, which is A and B both plus, and come to a stop, awaiting human input. Okay. Number 5 is, in the auto mode, the cycle will not start, which is the retraction of A, will not start until a delay of 5 seconds has elapsed. So after one cycle is completed, the automation will pause for 5 seconds, and then it will restart the cycle automatically. Okay, but this is not a condition for the manual mode. In the manual mode, you are the decider. How long you want to delay is up to you. So whenever you press the button, it will restart. But in the automatic mode, it will always wait a given amount of time of 5 seconds, and then it will start again. No need to draw an FRL unit, label each component. So that's something we can ignore for today. So let's start the drawing process. Now, the drawing process um, is very straightforward, but I strongly recommend using some methodical way to tackle each question. So whatever the questions are, you read the text and then you decide about three things. You decide, or you identify the sequence in the text. This one is generous. It has given you the sequence, which is clearly shown here. It's A minus B minus A plus B plus. If it's not given, you have to identify the sequence. So number one is to identify the sequence. So our sequence in this problem is A minus, then B minus, then A plus, then B plus. Okay, so how do we communicate? That's the automation part, so which you will have to decide. So retraction of A, sorry, I need to change the color. Retraction of A will initiate the retraction of B, which will initiate the extension of A, which will initiate the extension of B. And after B has extended, it will send a signal to A to restart the cycle. So we can use signals for each of the motion once they are completed. Like A, once A has fully retracted, it will create a signal called A0. That A0 signal will be sent to the second cylinder, which is B, and ask it to retract. Once B has completed the retraction, it will produce a signal B0. This signal will be fed into the first cylinder, A, and it will ask the cylinder to extend. Once A has finished the extension, it will produce a signal A1. This signal will be sent or fed to the second cylinder and will be used to extend that cylinder. Once B has extended, it will produce the signal B1. And this B1 signal will be fed to A in order to restart the cycle. Now, we have to keep in mind that in the automatic mode, we have to add a delay. So this thing, I will erase this part a little bit and add a delay of 5 seconds. Okay. However, there is a second option where we don't use the signal B1 to restart the cycle. We simply restart the cycle by pressing a button. This is the manual mode. So in the manual mode, we just press a button and start the cycle from here. Only in the automatic mode, we shall use the signal B1. Okay, and who will select between these two modes of operation? A selector that will decide whether to, so you can find that out here. There will be a 5x2 DCV with a lever or a button or a selector to toggle between the two modes, manual and auto. So this is the first step of solving this problem. That is to identify the sequence and understand the sequence. Then in step 2, you're going to have to list down all the number of cylinders, number of different valves, and so on. Now, when we do that, we have to be mindful about few levels in a circuit. So in a circuit, there are few levels. Starting from the bottom all the way to the top, the first level is called the input level. So the input level is the level 1 input level. After that, we have another level called the power level. And after that, at the very top of the circuit, there are output level. So input level, power level, and the output level. When we list down the things that we need, the components that we need, we have to put them each in their own inputs. Now, you have to know from definition, when we draw circuit diagrams are different from how we actually put those components in automatic circuits. So, but for clarity and for conciseness, drawing follows these three levels. These levels are non-existent for a real prototype, a real pneumatic circuit. You can put the component any way you like. You don't have to really follow this. But when you draw them, only when you want to categorize all the components in the lowest level or the input level. This is the lowest level. It is the intermediate level. And output is the highest level. So what we have in the lowest level and in the highest level and in the middle level. So in this one, there are two cylinders, right? For sure, there are two double-acting cylinders. You have to read the text and you have to kind of complete this table. So there are two double-acting cylinders. I can write them down. 2x double-acting pneumatic cylinders. In some question, you also have to provide a list of components. So this will be done at that in the beginning of the drawing process. So you're automatically getting this list. So there are two cylinders in this circuit. And since we have 4 different signals, A0, B0, A1, and B1, each signal have to be produced by a roller valve. So there are 4 signals. So we need 4 roller valves. Roller valves are level 1 components. So we have to put input level. There are 4 roller valves, RVs. So our list is now populating. Then we also learn about use of a button. For the manual mode, pressing a button briefly will start the cycle. So we need a button, push button. And buttons are usually level 1 or input devices. 1 button is required. Then we also need some speed control. As you can see from point 3, A will retract slowly, B will retract very fast. Slowly means we need some meter out speed control. Speed controlling are done in the power level. So we need 1 meter out. Meter out can be designed using unidirectional flow control valve. We need 1 of that. And quick exhaust valves are also used in the intermediate level. So we also need 1 quick exhaust valve. Quick exhaust valves are used to quickly retract or extend the piston. That we will need to connect with the cylinder. For each cylinder, we need 1 power valve. Power valves are the critical component, central component in automation. No roller valve or buttons will communicate with the cylinder directly. They will communicate with the cylinder via the the power valves. Because there are 2 cylinders, there must be 2 power valves in this circuit. So 2 power valves, PVs. So they have pneumatic pilots. And then we also know about the selector, which will select between the auto and manual modes. So we have to go and write that down. 1 5x2 DCV, or the toggle, right? That we need. And because at some point in this diagram, we have to create an or condition. We either go to the automatic version or go to the fully manual version. So that is done using a shuttle valve. So we also need in the input level one or valve or shuttle valve. Okay, so these are pretty much all the components I can think of right now. So there are, in the lowest level, we have 4 roller valves, 1 button, and 1 toggle valve, and 1 OR valve. In the middle, or the second level from the bottom, we need 2 power valves with 2 cylinders. We need 1 quick exhaust valve and 1 unidirectional flow control. And at the last point, in point 5, we can see there are some mention of a delay. So we will need a timer to also delay the process in the automatic channel only. So that is also a part in the lowest level. So we need a delay timer. Okay, and that's pretty much it. So we have created the list of components. Now in the next page, I'm gonna start drawing. So right now we have done the list of components, and finally when we start drawing, this is basically the drawing in the drawing process. So the drawing has commenced already. So in the drawing, you start by drawing the 3 different levels. So we will do that right now. I have copied the same question again. And here, I would like to take the ruler and start drawing the different levels. This will be our topmost level. And we don't need a lot of space for that. It's a narrow band. Okay, that's the topmost level. We only need space to draw the cylinders here. And the second level, which is the power level or the intermediate level where the power valves are drawn, I can have this much of space, should be enough. And draw again another line. So that's our power level. And finally, we should have a rather wide band for the input level, all the components for the input level, and I can also write down the names of these levels. This is a third level or the output level. This is the second level or the power level. This is the input level or the lowest level, where all the buttons, all the logical components, all the rollers and the signal accessories should be placed. And there is still a 0 level, which is pretty much the level where the FRL or the filter regulator lubricator are positioned. If not asked, you don't need to draw of FRL. And so these are the levels. Now we can start drawing. And the first step in drawing is to complete the top level, which is the actuation level. And we will draw things as they are in their default. So we have to draw a snapshot of the default position of the circuit, okay? So the default is both cylinders are fully extended. So we can start drawing that. I shall start by drawing a cylinder. Let's say this is a cylinder and it's fully extended. That means I have to draw the piston in the outmost position. And I also need to draw the piston rod fully extended. And then I can close the cylinder. It is a double acting, so it has 2 ports. The left port is the blind end 4 and the right port is the rod end. ISO standard says it is numerically given the number 2. The blind end is given the number 4. And then we will do the second cylinder. But for this one, let's draw a piston head. Pistons often come with different shapes of piston heads. I will draw the most basic piston head. Okay, and so this is now fully extended cylinder. I will draw a second cylinder right beside that, almost the same size. This one also be fully extended. Some cushion, and then the piston rod. And then I close this cylinder, and I will also draw a head for this piston. Right, so the two cylinders are A and B. You can also provide that in the block. Cylinders A and B, they will each need a power valve to operate. So we can now start drawing the power valve. Power valve are 5x2 valves, DCVs. 5x2 means they will have 5 ports and 2 positions. These 2 blocks represent 1 position each. So there are 2 positions, and 5x2 has 3 ports at the bottom, 1, 2, and 3, and 2 ports at the top. So the first port at the top is 4. The second port at the top is 2. So 4 has to be connected to 4, and 2 has to be connected to 2, just like that. 4 with 4 and 2 with 2. Okay, now I will draw that a while after. I want to first finish the power valves. So the of the 3 ports at the bottom, the middle one is called the source of pressure air, or the compressor port, and given number 1. The 2 other are 2 exhaust ports, namely port number 5 and 3. Same thing happens with the other block, but you don't have to draw all the blocks. So this in this position, port number 1 is connected to port number 4. Port number 5 is retired. Port number 2 is connected to port number 3. This is venting. So port number 4 is charged, and port number 2 is venting. In this second position, it is the opposite. So again, draw the 3 ports at the bottom, 2 at the top, and in this position, you have to draw the connection between 1 and 4, 1 and 2 in this one, and the 4 is simply venting to 5, and 3 is not in use, it's retired. Okay, so this is how the positions are shown, and I can make a copy of this because we're going to need a second one for our second cylinder. I'll just leave it like that, and there you go. And we can also start drawing the pilot. So a power valve, these are power valves. So let's write down the name: power valve 1, power valve 2. The reason why they're called power valves, because the actuation is done by pneumatic power, not by pushing or pulling or using any lever or something. They're actuated by pneumatic pilots. So on their left and right, they must have this pneumatic pilot. Pneumatic pilot means they are not moved by hand. They are moved by high pressure air. That's why they are pneumatic pilots. So I'll just draw the lines. Right now, these lines are open. So we have to connect some high pressure source to have inputs to these lines. Okay, so we will do that as we go down the levels. Now, we are not done in this level 2 because level 2 also should take care of all the speed control. Whenever we think of cylinder motion, we have to think in terms of the power valve, how the power valve control the motion. So if I look at cylinder A, port number 4 will be connected to port number 4 will be connected to 4. Like so. And port number 2 shall be connected to port number 2, just like that. And also here, port number 4 shall be connected to 4, and 2 shall be connected to 2. However, because these two cylinders do not move with the default speed, we have to put in some speed control measures. And to do that, we have to read the text. If you read the point 3, in the manual mode, A will retract slowly at a desired speed. So you have to be able to control the speed and make it slow. And B will retract very fast. So A needs a meter out speed control, and B needs a QEV or quick exhaust valve while retracting. So because the retraction happens when high pressure air goes from there and comes out from here, we have to have the meter out on this branch to make it slow. And to make the retraction of the cylinder B fast, we have to also do whatever we need to do in this line to make it fast. And we have to connect a QEV or quick exhaust valve to the B cylinder. First, let's do the A cylinder, and we will slow it down by adding a meter out. So I erase part of the line, or maybe not. To add a meter out, we simply have to draw a flow control valve with a check valve bypass connected in an orientation where we can make sure that only fluid that are flowing out of the cylinder are bound to travel across the FCV before they can get back to exhaust port. So they cannot, on their way down, the air cannot take this route. So we put this check valve in this orientation. However, when it's extending, the air does not need to go across the FCV because the check valve is open, so it will take this route instead. Okay, so it's a meter out speed control. We will do the same thing on the cylinder B. However, this one needs to retract faster. How can we make the retraction faster? By using a quick exhaust valve, a valve that looks like this. So it's a shuttle valve, also called an OR valve. There's the output. There's the input. So this is port number 1. This is port number 2. Now, we also, in this quick exhaust, we have an accessory attached to this one. It looks like this. So this is a leap that can quickly take the air that is taken at this point and send quickly to this side. So we will take this whole thing and connect it to the port number 4 of this thing here. We have to make some amends here so that there is enough space to move it in. Now we can move this thing in. And remember that port number 1 will be connected with this. And so port number 2 has to connect like that. Hopefully you understand that. So that is a quick exhaust valve, QEV. What it does, you already know, but again, when air comes in from this side and leaves from this side, the air does not need to go through all these things and finally get out. Instead, it can quickly come out from this blind side and get out this way to the space quickly. So that helps the rod to retract way more faster than usual. That is the job of a QEV. This one is a meter out speed control with a unidirectional flow control valve. It's a simpler thing. Everybody knows it. All right, so now we take care of the rest of the circuit by going in the level 1. The lowest level is oftentimes the most complicated level. So this is the methodology that I was trying to help you understand, that whenever you have any pneumatic question, this is how you want to proceed. You go make a step down approach. You go down from the top level to the second level to the third level. But before that, you must do this step to identify the sequence, to list down the things that you need, and then start the drawing. Okay, so now we already know that there are 4 roller valves that we will need. Each roller valve is a 3x2 DCV. They look like this. So I have drawn them previously. So I'll just show them here. So this is the roller valve. And if I turn them like this, so you can see this is a 3x2 valve DCV that are normally closed. So this is the normal position. Normally you see this port is venting to the exhaust. The port that we need to activate is this one. So once this roller is hit, then it will switch position to this new position, and it will become from off to on. So this is the default off position, and this is the on position, which needs to be actuated either by pressing on the roller or by a push button. So we have one of these now. We need 4 of them because we have 4 inputs that are waiting for signals. This is input number 1, this is 2, 3, and 4. So we're going to have 4 of them. I'm going to paste, not this one. I'm going to make a copy of this thing. And then I'll paste 3 more copies. And gradually, we're going to have to place them where they're needed. So roller valve 1, and I'll place it here for the first pneumatic input. Roller valve 2, I'll place it roughly somewhere here. Roller valve 3 can be where it is, and roller valve 4, that will be used with this one over here. And now I can show you where the connections need to be, like so, so, and so, and finally this one. So we can call them roller valves 1, starting with the 1 on the left, roller valve 2, roller valve 3, and finally roller valve 4. And because we already have figured out how the sequence is going to be and how the signals are flowing in the circuit, there are 4 signals, A0, B0, A1, and B1, where A naught is produced whenever cylinder A has retracted. And this signal is fed to the second cylinder to start the retraction on that one. Okay, so signal A1, A naught is produced whenever cylinder A has retracted. So we have to know when and how these signals are produced. When the cylinder A is fully extended in this position, we call that signal A1. When this piston will be fully back into the cylinder, it will generate another signal called A0. Likewise, for the two extreme positions of cylinder B, when it's fully retracted, it is B0. When the cylinder B is fully extended, it will produce B1. Now, we need to create the sequence so that by using this signal to complete or initiate the appropriate motion based on the sequence that we have. So signal A naught is produced by A, but is fed to B to create the B minus, which is the retraction of B. So who can do the B minus? Look at the power valve. B minus is the retraction of this cylinder B. Who can do that? This block can do that. And to switch to this block, who can initiate the motion of the power valve 2? That is the roller valve 4. So clearly, roller valve 4 needs to be delivered with the signal A naught. And with that signal, roller valve 4 will be able to trip the power valve 2 to this position, and as a result, it will be able to start the retraction of this cylinder. Once B has retracted, it will produce the signal B naught. And if I go back to that sequence diagram, the B naught signal was then fed to cylinder A in order to extend that one. So now let's go back and find out how does cylinder A extends. Cylinder A extends from this line. So this would be the block that we need to activate. And to activate that block, we need air in here. So roller valve 1 can send that air to this line. So roller valve 1 needs the signal B naught. So we will just write down signal B naught have to be fed to roller valve 1. With this signal, roller valve 1 will be activated and it will switch to this position. As a result, cylinder A will extend, and once it extends, it will produce signal A1, and we have to see what does A1 does. So A1 is produced by A but fed to B in order to cause extension of B. Now go back and find out how does the cylinder B extends. Cylinder B extends when we have air in this line. And to get air on that line, we need to switch the power valve to this position. And to do that, we need air on this line. So roller valve 3 is the one that needs the signal A1 to be able to do that. So A1 comes here. Obviously, B1 will be here. That's the only signal that is left. So all the signals are associated now with the appropriate roller valves, and the automation is now complete. However, we are not done with only the automatic version. Okay, so we will be required to do also the manual mode. We have to apply the manual mode using a push button. In the manual mode, pressing a button briefly initiate the cycle, right? And we have to use a 5x2 DCV to switch between this auto and manual modes. So this 5x2 is a DCV that will switch between the two options. Now the manual option starts with a push button, which we never have drawn yet. So I can make another copy of that roller valve, because a push button is also a 3x2 DCV, which does not have a roller. Instead, it has a button. So this roller have to be replaced with a button. Let me erase the roller. like that, and then add a nice button, just like that. Now it becomes a push button, and we can have the push button beside the roller valve. And now the roller valve and the push button both can send signal to this line. How can we make sure that signal from here or there can both enter here? We need an OR gate which will determine whether this or this can send the signal to here. Okay, so that's what we need now, because both the button and the roller valve 2 should be able to um, switch the power valve to this position and initiate the retraction of cylinder A. But we need to create a circuit that is able to handle both input component at the same time. So either or. So this is the condition we need between the push button and the roller valve. And that is done using a shuttle valve. A shuttle valve is something like this. It has one unified output, which is number 2, and it has 2 inputs. Both are given port number 1. So now you either can get air from this line, from the button, or you can get high pressure air from the roller valve 2. And then either of these components can send air, and then once it has the high pressure air, it can send it to this line, and this is called the OR gate. Okay, so that is the OR shuttle valve. So it means that either the left or the right port can either this or this, any one of these can send signal to this side and get the job done. Now, who decides whether the push button or the roller valve 2 will be in charge? That is the job of the toggle. So we need a 5x2 toggle in order to do that. To design a toggle, we have to draw a 5x2. It's a DCV, just like the power valve, but instead of the pneumatic pilot that we have with the power valve, it will have a lever. So we'll have a lever in place of the pneumatic pilots. And on the other side, we'll have to have detents, which will make sure that one of the 2 positions is held for as long as we want. And this is a 5x2, so it will also be able to have 2 ports here, 3 ports at the bottom, 2 ports at the top, 3 at the bottom, and the 2 ports on 2 sides are exhausts. Sorry, I think I'm drawing it wrong. So the exhaust port number 5, inlet port number 1, another exhaust port number 3. So this is 3, this is 1, this is 5. And for this one, this is the input. So these 2 inputs have to be connected to the first position. Let's say in this one, we can connect it to this, and this one to this. Excuse me. And this will be the exhaust. And in this first position, we are connecting port number 1 with port number 2. As a result, high pressure air is traveling to the roller valve. So if the roller valve was tripped automatically using signal B1, then this will be automatically there, and then it will be able to send the signal to the R. From there, the signal can travel to this one and do whatever we need to do in the sequence. However, if the lever was pressed like this, let me use a different color to, if the lever was pressed, then we would have activated the other position. In the other position, port number 1 would be connected to 4, and port number 2 would be venting. And this will be retired. So this is port number 5. This is port number 1, the compressed air source. And this is port number 3, which is the exhaust port. Right? So this is how we can decide whether to go push button or to go roller valve. If I go roller valve, which is now showing, then it is automatic. If we selected the push button or the second position, which is this one, it will be manual. So we then need to press the button in order to restart the cycle. And so it behaves exactly like the one we intended. So this is the toggle between manual and auto. That's our toggle for this circuit. I know this, the video is becoming really long. Finally, for the others, we have to also make sure that we put the components symbol completely. Now, it also says in point 5 that in the auto mode, the cycle will not start until a delay of 5 seconds has elapsed. Now, it is only going to affect the automatic mode. The automatic mode is this one when you have selected this block in the selector, and now the automatic mode only waits until signal B1 is produced, which will flip the position of the DCV, and then high pressure air can go on through the R valve to the right side of the power valve 1 and continue from there. So it's the automatic. Only this branch, if you only want to affect this branch by a timer, because that's what we need to add in order to add a delay of 5 seconds only in the automatic mode. So how to add a timer that will not affect the push button? So adding a timer here will affect both the button and the roller valve. Okay, we don't need a delay timer in the push button option because we can wait as long as we want, because this is the manual branch. We can wait as long as we want. So a delay does not necessarily make any sense. So how can we affect only the automatic branch? By adding that timer in this part of the circuit. If we only wanted to affect the manual thing, then we would do that here, because it is before the OR gate. So after this condition is fulfilled, we will send the air to the shuttle valve. So this is the ideal location for the timer. And now I'm going to show you only how to draw the timer. You can do the rest yourself. So I'll clean this up because this part will not be enough space for the timer. I will just show you the 2 open ports, 1 and 2. Okay, and I will show you where the timer goes. I will also have the port 1 and 2 with the timer. So the timer is basically a flow control valve, an accumulator with a flow control valve attached to it. So this is how you start drawing. You draw a vertical line, then you add an accumulator, which is something like that. This is the accumulator, and you also have to have flow control valve with a um, unidirectional flow control valve, so that whenever air is coming back, you are not timing it. So this is the completed symbol, sorry, of the timer. This is port number 2. This is port number 1. So 1 should be connected to 1. So this should be connected to that. And 2 should be connected to 2. That's what I'm saying. So this is the timer. And you have to add a delay of 5 seconds. So delay of 5 seconds. This is an ISO standard symbol of timer. The real symbol of timer is much more complicated than this, but if you draw this much, it will be accepted as well. So this will go here. The timer should come here, and then you will fully achieve all these 5 conditions. So 1, 2, 3, 4, and 5, and the circuit will be done. Remember that you always should follow these principles, these steps that I have done today in this video, in order to make sure that the circuit is always very, very accurate, and you're not missing anything critically important to the functioning of the circuit. I hope it was easy to understand. Watch it over and over. If you have any questions, try to get out of those confusions by watching this as many times as you need, and try to follow the philosophy. All in all, you must have good skill in drawing all these symbols from heart. Otherwise, and it will take extra amount of time. And if you are drawing these circuits in an evaluative environment in a given time, then it will be critical for you to know all the components symbols by heart, and that is one advantage you can have over the others that don't remember all these symbols by heart. Okay, so hopefully you guys will be benefited from this video, and thank you all so very much. Bye bye.